So the third type of the built-in delegates is going to be predicate. So function or func returns some type. Action only works with void types. The predicate works with only Boolean types. So let's go ahead and clean this up and write a simple method that will demonstrate this. So if I go ahead and create a static bool, and I'll just say is even. Taking a number, and I return the number, parentheses, num mod 2 is equal 0. So this will return either true or false if we give it a number. So now here, all we do is predicate, and then we say what type is that method going to be taking in. It's an int, and this will be even num is equal to is even. And now we can go ahead and console.write line, and we could say even num and then 42, for instance. And this will print out true to the console. And if I change this to say 43 and I run it, this will print out false to the console. So this is a very simple method, and I mean, it's a return type of Boolean. You might be wondering, well, why would we ever use a predicate? Well, it's quite useful when we get to collections, and we want to use collections for this. So let's go ahead and start this out with a list int of numbers is equal to new list int. And I'm going to go ahead and populate this list with the 100 numbers from 0 to 99. Int I is equal to 0, I is less than 100, I plus plus, and this will be numbers dot add I. All right, so we have this list of 100 numbers. And so now I want to pick out of there the prime numbers. So I'll create another list, int prime numbers is equal to new list int. All right, so the first thing that we need to do is we need to figure out how we're going to populate this. So a prime number, if you aren't familiar with that, is a number which is only divisible by 1 and itself. So prime numbers start at 2 and go up. In fact, 2 is the only even prime number. So you have 2, 3, 5, 7, 11, 13, 17, 19, so on and so forth. So it's numbers which are only divisible by 1 and themselves. So let's go ahead and create a method to calculate prime numbers. Bool is prime, int num. And this method is just going to, you give it a number and it will return true or false if it is a prime number. So the first thing is if the number is 1 or less than 1, well, it's not a prime number. So if num is less than or equal to 1, return false. Now if the number is 2, well, it is a prime number. It is a prime number. Num is equal to 2, return true. Now for every other number, which will be greater than 2, we have to check to see if it's a prime number. And so a prime number is going to be any number which is divisible by only 1 in itself. And so what we need to do is we only have to look at the first half of the numbers up to that number. So to do that, we'll just do var boundary is equal to num divided by 2, because we only need to look at the first half. And now we just need to write a simple for loop for int I is equal to 3, since we already checked 1 and 2 and everything below that. I is less than or equal to the boundary. And we can do I++, but we don't need to worry about even numbers. And since we're starting with an odd number, we can just do I plus equal 2, because we only care about every other number. And it has to be an odd number, it can't be an even number. And so now we just say if num mod I is equal to 0, which means that the number that you give it divided by some number which is half of num returns 0, which means it is divisible by that. Return false. So we just go through that. So if it finds something which is divisible by some other number, then, well, obviously that means it's not prime. If we get through all of the numbers there, return true, which means that, hey, we didn't find any other number that's divisible by, so obviously that number has to be a prime number. And so now we have this, so now we just need to populate this list. And so you might be wondering, okay, well, we'll just do a for loop. Well, it's much easier than that. Let's go ahead and create a predicate. And so this predicate takes in a parameter, int, that's that parameter there. And we're just going to name this as check prime is equal to is prime. Okay, so nothing is new there. But we can go ahead and say prime numbers. We're going to say, okay, this list is equal to, we're going to take in numbers, because that's a list, dot find all. Now this find all retrieves all the elements that match the conditions defined by the specified predicate. So if I do find all, now I can just say check prime. And so this is finding all the prime numbers and populating prime numbers there. And so now I just need to print it out. For each var I in prime numbers, and I can just do console.write line I. So now if I run this, I will get printed out to the console every single number which is prime from 0 to 100, well, 0 to 99. So now we can go ahead and spot check this. 2, 3, 4, oh, 4 is not a prime number. So now I have an error in this. And my error is probably up here. So I have, if it is that, oh, I forgot one other line. If the number is even, num mod 2 is equal to 0, return false. So if it is an even number, I need to return false. I thought I had wrote that, but I must have skipped that. The reason why this is not triggering on that is it's checking all the even, or all the odd numbers, and we're just skipping over the even values. So now if we run this, we spot check 2, 3, 5, 7, 11, 13, 17, 19, 23, so on and so forth. Notice that there is no even number in here. There is no number which ends, other than 5, ends in 5 or 0 because, well, 0 is an even number, but like 10 or 20. But 5 is all divisible by 5. None of these are divisible by 3 or really any other number. So this predicate here, if we create a predicate, you can use this find all method, which is part of the list, to pass it a predicate, and that will go through numbers and find everything which returns true from check prime.